Okay, I think we'll go ahead and get ready here. So I apologize up front for my voice. I've been talking for about a week and a half straight, and when I'm not talking, I've been sitting in 11-hour airplane rides between here and South Africa. So if I don't fall asleep and face plant in my computer, we're doing good. That is your water. Yes, it is. So my name's John Brock. Excuse me if I just sit and not stand up at the podium, because I'm going to do a little bit of code and weird things, and I want to have a decent spot where I can run my mouse. I'm a product manager for Oracle Jet, just a heads up on the up front. So I'm going to talk a little bit about what it takes to do JavaScript clients in an enterprise space. And with those caveats kind of in discussion about how we're going to fit and what we're going to look at, we'll talk about a little bit about how Angular plays in that, how maybe React plays, Vue.js, those types of things. You will not come out of this at the end of the session going, oh, Angular is the one to go with, or Jet is the one to go with, or something like that. I'm not going to declare a winner today. We're just going to talk about what the different options are. And by talking about what these different scenarios that you have to think about when you're building out high-scale enterprise-type applications, you guys can figure out what's going to work best for your environment and work best for your shop. So I think everybody, you've probably, by the end of the day here, you've seen this safe harbor statement a zillion times. I don't plan on talking about schedules, so it doesn't really matter. So enterprise software, what does that actually mean in this day and age? If we look at enterprise in Wikipedia, it basically says that we're dealing with software that organizations or large companies deal with and actually interact with, versus the consumer software where an end user might be using it more in an everyday life. As you start to look through this, I remember back when I worked at Sun Microsystems, we just kind of looked at enterprise software as this really large scale, high availability, those types of things. And that's what it really kind of meant to me. But as you go searching through the internet and trying to find out definitions for things, you often come up with people that have their own strange definitions for things. This guy was out on Stack Overflow, and he basically said enterprise software is when you make it complicated enough that you can build a consulting business around it. Yeah, okay. Maybe for some of us that actually is true. But for us, we start to deal more in this day and age about client-server relationships and how those are starting to change in this enterprise space. And we've always had the back end and these big data centers that we dealt with and things like that. And the clients usually were just browsers. And if you were really lucky, you had something like this where you could actually have like really a lot of browsers and big ones. I did a tour through a Google office recently up in the Seattle area, and every desktop actually had these 3 monitors set up similar to this. So it makes you kind of want to go work for Google. Hopefully I don't have any Oracle bosses in here. But nowadays, it's not so much just that browser, right? Now it's devices of every kind of shape and size, and touch devices, and even laptops like this one that I'm using right now is already touch enabled. I even had a gentleman contact us from Oracle's Belgium office, and they're doing a digital experience lab, and they got a new Samsung 44-inch touch screen. And he was asking if Jet, would be able to run data visualizations on this touch screen so people could walk into the lobby and start touching it and stuff, and it actually worked. I told him I'd be glad to test it for him if he could order another one and send it over to me, but he wasn't falling for that one. So we're going to take a look at this environment of where you really have to think about where does that client hook into and what kind of environment in the back end is that actually looking at. We're going to look at 7 different steps. I just list them up front, but we'll cover all of these. There's kind of one in the middle that's kind of a half step that I've kind of run into over the last few months, and so I added it in. But let's start from the top. So resist the hype. JavaScript in this day and age changes constantly. About every 2 weeks, every month, there's a brand new framework or a brand new library that's going to save you the world. And when you're dealing with enterprise software that can take a year, 2 years to write, you can't go chasing after that latest and greatest thing. It doesn't mean you have to stay on old libraries forever, but you have to be really careful that what you're actually taking on is stable. You know, it's not some guy, one guy working on it out of his garage and you're wondering if it's got security holes in it or if it's going to scale when you need it to and things like that. You want to work with things that are a little bit more mature, a little bit more proven. You also don't necessarily always want to go to these new client-server architectures. There are places where on-premise or, you know, proprietary software type situations make sense, such as air traffic controllers. If they ever start landing planes on a phone, I'm taking the bus. I mean, it's ridiculous, right? But we actually had somebody come to us in an air traffic controller situation, and their bosses were just screaming at them, we need to move to the browser. The whole new web thing is the new thing. And it's like, look, people, you actually have your own IT group in the floor right below you that maintains this software on a daily basis. There's no way you're going to move this to the browser, let alone you'd want to. And there are multiple environments that are this way. But you just have to kind of resist that hype. You have to really think about where you're going. But at the same time, there may be ways to extend or, you know, look at certain areas that can actually take advantage of this new client-server architecture. So even in that air traffic controller environment, you may look at things where maybe you set up a phone app that does alerts in certain situations to get the manager and get his tail back up into the tower if he needs to be, or maybe there's some reporting systems that you can do that aren't quite real-time urgent type situations. So you don't always want to move everything, but there may be things that you can think about out of the box and see if there's maybe another way to go about it. The second thing that seems to come up quite a bit is data. And this is the situation of, we had server-side languages, JSP, you know, JSF, those types of things, even things like Ruby on Rails or whatever you were doing on the back end. And in a lot of those environments, you got used to making direct database calls. And you could pull down 2 gigabytes, or not gigs, 2 megabytes of data really quickly in an XML format or even a JSON format and manipulate it on the server, and then what you sent down to the client was just the already processed data. And what we find is a lot of people will turn around and they'll just take those endpoints, those REST calls or those database calls that they were making before, and they'll turn them into REST endpoints. And then they go into this new architecture and they can't figure out why their browser takes so long to load. Well, it's bringing down 2 megabytes of JSON across the wire, and then they're trying to manipulate it on the client. Even worse, you'll find people that'll connect still to a SOAP interface, bring down XML, and then for some reason they want the browser to convert XML to JSON, which is just a nightmare. So you have to really start thinking about, is your data too large or is it too small? Or is it just right for the client that you're starting to work at? This architectural change is actually the starting point for any of these application changes. You really want to look at the architectural change of client to server and what the data is going to do first. It's even more important than how you're going to rewrite the client itself. We get the case where the guys are bringing down really large data situations. That's the most typical. The other side is the microservices, another big buzzword that people like to chase. We had a situation again where an application, they said, oh, we're not gonna bring down this big thing, we're gonna go to microservices. They had a REST endpoint they were doing a profile page. They had a REST endpoint for the address. They had a REST endpoint for the name. They had a REST endpoint for the avatar. They had another REST endpoint for the location map or whatever the heck it was. And the next thing you know, they're coming up on our internal forums and they're like, I have these 5 different REST endpoints and I'm trying to put together a form. How do I join those all back together so that I can actually pull something? And it's like, well, in the database, it's called a join. You know, and it's like, shape your data on the server. Use the database for what it's really built for and simply bring down the data that your client needs. So don't go too small, don't go too large. You have to think about that relationship that the client's doing. Now this is irrelevant of what you're going to use on the JavaScript on the client. It doesn't really matter. But it's really, really important to be thinking about that in an enterprise space. Because a lot of times when you start to find out where your performance bottlenecks are, they're going to be at that REST endpoint. It's not going to be at the client. And so it's really important to figure that part out. So when it's a right fit, everything actually works really well. And you can do some really crazy things on the client to make that right fit work. So let's take a quick look at a demo. So in this case, I'm going to use Apex. So anybody guys use Apex out there? So I'm going to kind of, what's that? There's no display. Where did it go? No connections there. Come on. It's me. I'm good. There we go. So I'm going to use Apex, and I'm just going to use their SQL workshop and the SQL command side. Apex is a fantastic utility, or application. We really like it. On the Jet side, they happen to use our Jet charts and graphs, so we have a good relationship with them. Yep. In this particular case, I'm using the SQL workshop, and I've got some ORDS scripts that I'm using, the Oracle REST Data Service. And for myself, let's see here. Let's go with here. So I have a REST endpoint, and it's a little hard to see this. I apologize. It's hard to make this bigger. Well, there I go. Make it a little bit bigger. So I have this REST endpoint that just goes to EMP/, and when I hit that, I'm just doing a select star from employees. So I'm getting all of the fields in my employee database. And that's all well and good. That's going to be one thing that I can hit maybe when I have a big browser. But I also have a mobile endpoint. And my mobile endpoint is hitting, let's see, I'll go up here, m/. So I'm going to, if I actually do a URL and it's m/employees, then just pull in the employee number, the employee name, and the hire date. So this is thinking very carefully. I'm saying if I'm on a large screen, give me everything from the database. I can handle that. I'm going to display a lot of information. But if I'm on a mobile device, maybe I only want to show a few fields because I have a much smaller interface that I'm dealing with. And while this is really simple in a very, very simplistic case, the applications that we start to put together show something like this, where when I'm on a full-size monitor, it shows me all the different fields. But if I shrink the monitor down and refresh the app, now I only get those 3 fields. So what I'm doing is this thing called responsive JavaScript, and I'm going to cover responsiveness in the next step here in a minute. But there is code that we can write, and certain JavaScript frameworks have this capability where I can go into the JavaScript and I can basically write into my JavaScript saying, if I'm dealing with a certain screen size, in this case I've got responsive utilities, which I've defined up above here with the RU right here in this little library that I have called responsive utilities. And I've said, if it's a medium screen or smaller, then go to this URL as my REST service. If I'm anything less than that, then use my mobile, or medium on up rather. Anything less than medium, go to that mobile endpoint. So now I'm able to dynamically adjust the data that I'm actually pulling in. And there's, like I say, there's certain different types of frameworks that have this responsive utilities, and we'll talk to that in a minute. But it actually allows you to be a little bit more careful and a little bit more thought-provoking on what data you're pulling down. What is there about mobile devices that really makes this type of thing really important? Maybe the bandwidth, so 4G, 3G. You know, I was just in South Africa, and I was talking to their second largest health insurance company now, they're called Liberty Health. And they're doing data entry pretty much all the time. It's just these big fields of data entry. And their biggest problem was that everybody's moving to these big fancy new UIs, and you know, they're pulling data and they're doing charts and everything else. But these guys have got insurance, you know, hubs and offices sitting off in remote places in Africa where 3G is like really good, and 3G data on mobile devices. And so they have to be very careful about what data comes down across the wire. So situations like this are really, really important. And so shape your data for the device that it's actually going to go to. So let's go back to slides really quick. So the next thing is that responsive design. So everybody familiar with responsive design? You know what that is? Okay. So responsive design is just kind of expected in this day and age. 2 years ago, maybe 3 years ago, we were starting to get into it, and primarily it was all CSS. It was basically if you shrunk your browser down or you went down to a different device, the CSS would reshape things or it would hide things in your browser. And it would help you kind of make your application respond to the device, thus responsive design. But as we also find nowadays, this JavaScript responsiveness is also something that's really important. It was kind of the holy grail up until about 2 years ago when there were a couple of libraries that started to come out that allowed us to deal with that. CSS originally was just designed to kind of give you a look and feel of your document. It really didn't control things based on the devices. Again, we had the big browsers, that's all we really had to do. It was just there for laying things out. But with CSS3, they broke everything down into these individual modules. There's over 50 different modules that make up the CSS3 specification. And one of those biggest ones was media queries. Media queries allowed us to start looking at the device, the actual width or viewport width of the devices that we were displaying in, and then adjust our CSS based on those device sizes. So we could do things where we could actually hide, see we have a big screen and we're showing a bunch of charts on this side. When we get down to a small space on a tablet, you don't have as much space to show all these things, so you just hide those images or hide those charts. Well, that was great, and it allowed it to look really cool, but behind the scenes, you were still making those JavaScript calls. You were still bringing down the data that was filling out those charts. They were just hidden. So that became, everybody started thinking, well, isn't there a way that I can dynamically adjust whether this stuff is happening even on the business logic side? And that's where we got into responsive JavaScript. And there were things like response.js, which was the very first one that came out. It was a really cool library and pretty easy to implement. And then another framework, a JavaScript framework called Foundation from a company called Zerb, which if you haven't heard of this, you should go take a look at it. It's actually a really cool JavaScript framework. And they have a feature of it called interchange, which also brought this stuff in. And Oracle Jet, we actually brought it in as well in a version about 2 years ago and started doing these capabilities of doing this stuff. Well, it not only allows you to adjust the data on the back end like we did just a minute ago with the REST endpoints, but it also allows you to dynamically show and hide, or load and unload instead of show and hide. So with CSS, you're simply hiding something. It's still in the DOM. It's still in your download that you're downloading into the device. But with JavaScript, we can put conditional statements around the DOM objects, and we don't even load those at all if they're not of the viewport size. So let's take a look at how we can do this. And it probably just dropped back. Oh no, it didn't. Hey, look at that. Good. Okay, so in this case, I'm looking at, let's go ahead and bring up the app. So in this particular case, we've got this little screen and it's just got a couple of images on it. And as I shrink this down, as I shrink this down, it is the end of the day. As I start shrinking this down, the images disappear, okay? So responsively just hiding some images. Very simplistic example. They both hide, they both disappear. Let's take a look at what's actually going on in the UI. So if I bring up the browser tools, and I tell it I want to inspect that image. Let me see if I can increase the size of this a little bit. Yeah, I can. Okay. So here, I've got image A, and I've got image B. Image A is simply being shown and hidden using CSS. So if I look at my CSS, I have this media query that says, The max width is 767. So anything smaller than 767 pixels, just set display none on image. But in my JavaScript, or in the other section here, I've actually wrapped image B in an if statement. So what I'm doing is I'm saying, if this conditional situation is true, then go ahead and show what's inside of it. If not, don't even load it in the DOM. Don't even put it into the object model itself. Again, extremely simplistic, but imagine if you've put this if block around an entire chart or around an entire table that's making REST interfaces and so forth. So you're actually, shrinking your DOM by quite a bit and what has to be sent over the wire. So let's take a look at that in this situation. So here's image B. It's wrapped with a conditional. Here's image A. So as I start to shrink this down, okay, they both disappeared. Image A is still in the DOM, but image B is completely gone. It's not even in the DOM at all. And so it's kind of cool in that you can just simply do this responsive JavaScript where it adds and removes things right directly out of the DOM. Again, simplistic, but it is something to think about. And as you start to get larger and larger applications that have to be able to show up on these different devices, this stuff gets really important. So another thing that came up when we started talking about design, and I've heard this multiple times now, is if you're of a company that is either really large, like Oracle, we have our own design shops or design teams, basically. We have a UX and a UI team that does all of our HTML and our UX design and so forth, all our CSS for us and so forth. You can go on the opposite side where maybe you're a smaller startup and you don't have that expertise in-house, so you'll actually outsource that to a real design shop. And they'll do some beautiful HTML, they'll do all your images, they do this really cool CSS, and then they hand that back to you as just straight up HTML and CSS. And now you're supposed to tag all that into your data on the back end. You're supposed to connect all that up to make the dynamic pieces of it. Well, this used to be kind of a problem when we were on the server side. I did a lot of JRuby stuff and things like that back when I was at Sun Microsystems. And we would get these design shops that would bring us these HTML files. And then we'd have to figure out in the HTML how to change up things and put in our tags to the dynamic side of the tags and what was going to get loaded and so forth. And it was a little more difficult to kind of mix all this stuff in with what was going on the server. Well, the same thing's going on now on the client. We started to have a pretty good life where everything was being done in HTML and you could just get these things brought over from these design shops. And it was fairly simple to add some binding layers in and things like that to make the data dynamic while everything else stayed the way it was. Then came along another very popular framework. And that changed up it changed into what we call JavaScript forward. So there's HTML forward and JavaScript forward. HTML forward means that the framework usually relies on the semantics of HTML. So Angular, Vue, and Jet all do HTML forward. You actually develop real HTML and then you're doing some binding into a JavaScript layer behind the scenes. You're using HTML for its semantics. You're using headers, you're using sections, you're using footers, things of that nature. React came along and decided it was JavaScript forward. So you're actually generating HTML out of JavaScript. Well, when you're using these design shops, that's a problem. Because now you've got all this HTML that's really pretty. CSS stays the same, that's not much of a problem. But now you've got to take all that HTML and figure out how to fit that into a JavaScript generated environment. It's much more difficult to do. It's not impossible, you can still do it. But it is something to think about as you start to chase these frameworks around and which one you're going to do. What is your environment that you have to fit these frameworks into? So that's something just to kind of think about. The next one that we come on is number 4, and that's frameworks versus libraries. So again, we start to look at this environment where we have full-on frameworks that are prescriptive frameworks. Angular is a good example of that. Ember, if you've ever used Ember, it's probably the most prescriptive framework that's out there today. A great framework, but you use it the way they tell you to use it. There's no fudging around about messing with it. You just follow their way to do things. Angular is gotten better with the Angular versus Angular JS, the older version, but there's still pretty much you learn the Angular way of doing things. Same thing with React. You learn how to do things in the React way. But it isn't always that way. If you need something that's to be a little bit more modular, or something to be a little bit more flexible, there's another way of doing things in this library approach. So as you start to look at the ecosystem that's out there, it's just constantly changing, right? There's always something new coming along. Now, whether you want to go chase that down or you want to stay on something that is more of a prescriptive framework, that's a choice that you just kind of have to think about, and where your design shop is and where your development practices are. How often do you have to release new versions and things of that nature? But even on the back end, from your testing frameworks and scaffolding and things of that nature, these also change constantly. So when we at Oracle started to look at a new JavaScript framework, we started about 5 years ago when Angular JS was in 1.3, I think somewhere around there, 1.3, 1.2. And we were trying to find a corporate standard. Things were changing very quickly, and we saw what was going on as far as this moving to this client-server architecture. And we said, we need to actually come up with some sort of a corporate standard, or we're going to be insane trying to maintain all these apps. And corporate architecture was being inundated with requests to try out new frameworks and new libraries on a regular basis. So we were tasked with coming up with this corporate standard. And we went out and we talked to all the corners of Oracle, from hardware to what we call global business units, to the middleware group, to all these other groups around the platform groups, Solaris and Linux, things like that. And we said, what are you doing in the JavaScript space? And we found some were using Backbone, some were using jQuery, some were using some other things. And we knew immediately that we were going to have to be really flexible. And we were going to have to build something that was more of a toolkit versus this prescriptive framework approach. And so we started looking at individual libraries that met specific needs. Like if we needed routing, we'd find the best routing library. If we needed lazy loading, so resource management, we would go and find the best library for that. And we just kind of looked at all these different approaches. And we broke it down into different ways of looking at those libraries. We said, well, okay, let's first just start at, do we want a framework? Do we want an individual library? How do we want to do things like that? Then we looked at the modular systems. So we knew that we had to be able to do lazy loading of resources. Anytime you have to have a large-scale application, that very first landing page has to load instantly. Sub-second if you can do it, sub-2 seconds usually. So we needed to be able to load other resources as you loaded pages later on. Our build systems, what was the latest and greatest? At the time we started looking at things, Grunt was the big thing. Then Gulp came along for about 6 months. And then Brunch came along and replaced Gulp 6 months later. It was the craziest thing you'd ever seen. It was just like every 6 months something was changing. And the testing frameworks did the same thing. Jasmine was the biggest and coolest thing for a long time. Now all of a sudden that's disappearing and being replaced by some other things. So we just kind of broke them down into individual areas and looked at those areas and tried to find the best of breed in those areas. In the end, we kind of came down to what are the pros and cons of both of these. The framework approach is actually pretty simple to take that on and get up to speed pretty quickly. There's great resources, educational properties out there. You can come up and learn the Angular way of doing something or learn the Vue.js way of doing something really quickly. And it's actually nice. It isn't quite as flexible as the library approach, in that if there's some new thing that comes along that really is, really cool, and it is something that will save you a lot of time, everybody's going to it pretty quickly, you have to wait until that framework picks it up. You can't really, jump on top of something new and just pull out a piece and put in a new. You go with the direction they go. And that's fine if that's where your company wants to go. Now the library approach can take a little bit longer to learn. Some people will say it takes less time because each of these individual libraries have a full community around them. They have all their documentation and everything else. But really, using them together can take a little bit of time. And if you were to try and do this on your own, it would take even more time because you have to figure out what libraries work with each other really cleanly, which ones don't. Not everything works really good. Some things will step on top of each other. In the Oracle Jet side, we settled on a few of these different libraries that you see here. So we chose Knockout for just the binding layer, the two-way data binding that we did. jQuery was just jQuery. You know, everybody used jQuery out there, and so it was just kind of a thing we threw in. We actually use it very little, very little inside of ourselves, but we have a lot of developers that like to use it still. We started out with jQuery UI, because jQuery UI there were UI widgets everywhere. There's thousands of them out there. And when you're building a brand new toolkit, you know, we were adding UI elements constantly, but we didn't have that big full breadth of everything that we needed. And we knew we wouldn't for a good couple of years while we kept building. But while we were doing that, we had built everything around a jQuery UI widget capability so that anything we didn't have, someone could just go out to the internet and grab the jQuery UI version of it and drop it in, and it would work with Jet automatically. So we kind of based ourselves off of that early on. Now, 5 years later, we're finding that the web component specification has now reached a stage where web components are supported across pretty much all of the major browsers, at least a large degree of them. And so with Jet 4.0 that we released last August, we moved everything over to web components. And that's the direction we're moving forward. Everything that we do going forward is following the web component specification, the HTML5 web component spec. Now, we were lucky enough that we were actually able to just take our jQuery UI widgets and wrap them as web components to start with. So our entire breadth of UI elements, everything else, they're all still there. You can just use them. And then over time, we're stripping out the jQuery UI widget part and just replacing them with straight up HTML and JavaScript and so forth. But the API or the DOM elements that you're creating stay the same. Your code wouldn't change at all. We'll just change it behind the scenes on you. Require.js we chose for all the lazy loading. Now, the biggest thing that everybody looks at on these things is they go, oh, gosh, Knockout and Require.js, those are like my grandfather's libraries, right? They're 2 years old. And that's true. You know, I mean, this whole thing that comes back to chasing the shiny object, right? So we'll talk a little bit more about that in a second, about the Require.js side, and go into that a little bit more. But the bottom line was we needed to be modular. We needed to be able to come up with a toolkit that allowed people to use as little or as much of this thing as they needed. And that fit our need a little bit, needs a little bit more when we were building things up. No matter what you use, modularity is key. Anytime that you're going to start building out large-scale applications, you have to be modular. It doesn't matter if your JavaScript is modular or your CSS or your HTML, it all has to be modular. You should be using something like Sass, which allows you to break up your CSS into CSS pre-processing, so you can have smaller chunks of CSS that get built together into a single file. You use HTML templates and things like that for loading in different segments of HTML, so your other pieces of your team, other engineers in your team can work on different sections of your app at the same time. And the same thing goes for JavaScript. ES6 modules are a good way to work. There's also AMD, which is what Require gets us into, and things of that nature. But the modularity and the ability to break down your app into smaller pieces that multiple team members can work on at the same time is really, really important. Now, why am I showing shipping containers when I talk about modularity? Well, you know, okay, they're containers, they're small things, and it's kind of cool. When I started doing the research for this talk, one of the things I found about this that just blew my mind was another concept of modular code is that you're building chunks of code that are reshared, that are used by other people in different ways. And the one thing I found in doing open source, and I've been doing open source for probably 15 years now, back going out of the Sundays, and it's one of the things that's really cool is you build something and you share it up on GitHub or you share it out somewhere, and somebody will take those libraries and build software that you had no idea what they were going to do. You know, it wasn't what you originally wrote the code for, but all of a sudden it works, right? So in this particular case, it turns out that around the world, there is this huge excess of shipping containers. Apparently they have a shelf life, and you can only use them for so long to actually ship things. And they are just sitting rusting in yards all over the world. Well, architects have started to take these shipping containers, and they've started building homes out of them. Every one of these homes is actually shipping containers pulled together, the frames of them put together in different ways. Now, these are really fancy ones, and I'm sure they're really expensive. But they're also building miniature houses or small houses for university students or for low-income areas where you've got people that are living in poverty, living in tin shacks or cardboard shacks. You can drop shipping containers in that have actually got sturdy walls, and you can put facilities inside them with beds and things like that. And you can put these in for people to live in. So it's kind of cool that something that I'm sure nobody ever thought about when they were building shipping containers that they were going to be used for housing. But it is a segue, I understand that, but it's kind of cool. So I put it in there. So back to modularity. Some of the biggest things that are out there today, Require.js is the grandfather of them all. It's been there for a long time. Webpack is the new cool kid on the block that everybody wants to use. And then ECMAScript, or ES6, is the standard. That's the actual JavaScript standard, and it has its own modularity built into it as well. And then there's Browserify, which kind of sat somewhere between Require.js and Webpack before it was just kind of shoved to the side. What we want to look at in this is that Require.js had all these cool capabilities of doing lazy loading. It has two different functionalities. It has the ability to build modules, which are reusable JavaScript chunks called AMD, asynchronous module definition, and you can lazy load those at runtime. It also has the ability, what they call R.js, which is to take all these different JavaScript libraries and compile them into a single bundle, into a single JavaScript file. And it kind of shrinks them down into it. And in the days of HTTP 1.x, the whole concept was try and get as small a file as possible, but download as few files as possible. HTTP 2 kind of changed that because you can do asynchronous downloads and so forth, and so you can now download multiple files. But that was the whole premise of getting things packaged down into small enough files. Webpack came along, and Webpack has this really cool feature called tree shaking, which it does the same thing that R.js does on the Require side, but it actually analyzes the code and it says, hey, there's a bunch of chunks of code in here that aren't even being used in your app. I'm going to get rid of those. I'm just going to drop them out. And so now those bundles that you're creating can actually get pretty small. And it's a really great feature. It also has a feature of what they call hot swapping, which allows you to kind of do some different things at runtime as well. The one thing it doesn't do, though, is it cannot do lazy loading at runtime. It can't do asynchronous loading at runtime. You have to package everything up at build time, and you have that one library that goes down and gets loaded, and then everything gets pulled out of that library at runtime. This became a problem for us because we have internationalization built into Jet, and we ship with 28 different languages and 196 different locales. And we've got all those different resource files for all those different languages. And when you use Require.js, Require.js has the ability to reach into those resource files at runtime and lazy load them. When we had people coming to us and saying, hey, I want to use Webpack instead of Require.js, we said, well, great, but you can't do all this internationalization at runtime. And they're like, oh, no, yeah, we can. And we're like, no, you can't. And they started looking into it. Well, it turns out you can't. So they would end up having to bundle every single resource file that we had for all of our languages. And that nice tiny bundle that you got with the tree shaking and everything suddenly became 8 megabytes. And you completely defeated the purpose of using this great new cool thing. So you have to kind of watch out for what you're chasing after. And again, this goes all the way back to the resist the hype. It is cool and it's got some really great features, but when you get into enterprise grade applications where you've got things like internationalization, you have to make sure that you can still fit into that. Now we're doing some work on the Jet side to actually write Webpack plugins that will allow it to do that runtime loading and so forth, and we hope to see that later this year so that Jet will run with Webpack as well. Now I kind of hesitated on ECMAScript, and the reason for that is that there was a lot of discussion in the ES6 working group when they were building out the ECMAScript spec with loading in or having their own module loading system. It was called System.js. And it was supposed to be asynchronous and allow you to load things in an asynchronous way. But they weren't able to actually make it work by the time they wanted to kick the spec over the wall and actually produce ES6. So what they produced was a module loader that's synchronous. So we've got a lot of people that are like, oh yeah, I need to use ES6 modules, and I'm just going to use their system loader. And they're like, great, you're going to serialize your entire application. So instead of asynchronous loading, where you can call out to all these different REST endpoints or call these different resources and everything's coming down at different times, you now serialize your app and you're just waiting for everything to come in one after the other. In an enterprise app, that's not going to work. Even in small apps, it's not going to work. So again, brand new thing, really cool, but watch out for the details. So, number 6 is what we call abstractions. And abstractions are where we kind of take technologies that sometimes people are new to, or sometimes they've been around a while, but people have been used to something else. And they want to use something that allows them to use this new cool thing, but they don't want to quite go all the way to there. And in this particular case, there's a bunch of these new libraries out. And some of them, like Sass and Less, are CSS. They allow you to work with CSS in some really cool ways. They allow you to, instead of having to deal with thousands of lines of code and just straight CSS, they allow you to break it up into individual pieces. They add conditional statements into CSS, so you can do some if statements and things like that. You can do gradient generators and also other kind of cool stuff in CSS. And it actually is really nice. It allows us to work with really large applications. We also have things like CoffeeScript or PureScript or TypeScript and Flow, which basically took the JavaScript language and added a layer above it to supposedly make it easier to write JavaScript. TypeScript's the most popular one. And TypeScript, for those of you who aren't familiar, how many of you actually write JavaScript code? Okay, fair number of you. How many write Java? Okay. So the biggest difference between Java and JavaScript, they are apples and oranges, by the way, they are not the same, is Java is strongly typed. A string is a string, a number is a number, or an int is an int, and so forth. JavaScript, hey, 2 in quotes equals 2. That works. JavaScript is loosely typed at best. And JavaScript just kind of interprets things or for whatever it feels it wants to be. And that freaks out Java developers. They can't stand it. Usually if you take a Java developer and you show them JavaScript, they just start screaming when 2 in quotes equals 2 and it comes out and says true. That should never happen in the world. So TypeScript comes in and TypeScript starts adding in types and type safety into the JavaScript language. So when you start to actually write TypeScript, you're actually saying this is a string, this is an int, and so forth, and then it transpiles that down to real JavaScript in the end. And that works really well. In Oracle, I've got a situation right now where there's a very large development group that's all writing their applications traditionally in ADF. They're all Java developers. They decided 4 months ago that they're all going to move to Jet. So I have 10,000 developers coming from Java over to JavaScript. They don't know JavaScript. Yeah. And so we're implementing TypeScript really, really quickly to save ourselves much as anything else, because I don't want to have to deal with these poor guys and try and figure out what's going on. In the end, you're just trying to abstract above so that the picture is a little bit clearer. No matter what you're trying to do, whether it's trying to get down to that JavaScript layer, you're adding these abstractions in just simply to try and get a better view of what's going on for that developer. You want to make it as easy as possible for those developers to get their job done. And that's what those abstraction layers really do. So my final step is to take a look at what corporations are doing out there with JavaScript today. So you've got Microsoft, which actually is investing really heavily in TypeScript. TypeScript's actually Microsoft's. They're also doing a whole bunch of other things with Angular and things of that nature, and a lot in the JavaScript open source space. They created a new coding editor called VS Code, Visual Studio Code, that's free and easy to use. It was actually VS Code I was showing earlier. Some really cool stuff. IBM was the original founders of Dojo, and they still use it in some of their apps, but they've also now moved over to Angular in some cases, and they're doing some other open source stuff as well. Salesforce has a thing called Lightning, which is based on Aurora, which is an open source library that they created and open sourced. And they're writing all their stuff on top of that. Same thing with SAP. SAP has a UI layer called OpenUI. And they have a design standard called Fiori, which is very much like Google's Material Design or Apple's iOS. They have their own design spec. Oracle has one called Alta. And Alta UI is our design spec. ING, a financial company called ING, produced this thing called Spectangular, of all weird, crazy names, about 3 years ago. And it was a UI layer based over the top of Angular. And it was based over Angular.js. Unfortunately, I mean, it was really cool when they first did it, and we were all kind of like, wow, really? You guys are doing some pretty cool stuff. And we started watching it to see where it was going to go. Unfortunately, it was one of those throw over the fence to open source, and they've never touched it since. It hasn't been updated in over 2 years. But it's out there, and it's kind of cool. PayPal has this open source project called Kraken. Now, it's all on the server side. And it does some really cool stuff with authentication. It uses Express, and it's extended some stuff for doing microservice payments and things like that. And it's really worth looking at if you're doing some back-end stuff. And then, of course, Oracle open-sourced Oracle Jet, which you've probably seen in some of your sessions. It probably got called out that they were using Jet. But in a lot of the other ones, you probably had no idea. So how many of you saw sessions today that used Developer Cloud Service or Mobile Cloud Service? IoT service, BI Visual Analyzer, if you saw some big cool VI charts and stuff like that. All of those written in Jet. Visual Builder Cloud Service was one that was shown earlier just before this one. That's actually written in Jet, and it actually builds Jet-based apps. So it's its own IDE that we've built. And so I'm going to show you a little bit about Jet. And I don't want to make it a product pitch. That's not what Oracle Code's about. But I do want to tell you a little bit about what we've done. So as we talked about, Jet's a toolkit. So it's not a prescriptive framework. We actually went the library route. We actually chose the individual libraries to meet specific tasks. And when we put all that together, we came up with the libraries that we were talking about earlier. We also added web components, and we started doing things in web component specifications. We use Cordova for all of our mobile capabilities. It's modular, so you can use as little or as much as you need. We produce basic UI interfaces, as you would expect, buttons, input fields, all that kind of fun stuff. But we also produce some pretty sophisticated data visualization stuff. I pretty much would guarantee that as far as open source products out there, this is the most advanced data visualization set. Now, D3 is a visualization library in the open source world, and it's really cool, but you have to go build your data visualizations using D3. These things are already put together. These also meet all of the accessibility guidelines that you will have to meet for 508c3, and anything that you have to meet within the WCAG, the Web Content Accessibility Guidelines. So if you're dealing anything in the public sector, any governments, 27 different countries and regions, the EU, Australia, US, all these different ones, all require you to meet those accessibility guidelines. All of Jet's UI components meet those accessibility guidelines out of the box. And these are just a few of some of the dashboards that different products have put together. Oracle Management Cloud is also using completely written in Jet. Oracle Commerce Cloud's written in Jet. So quite a few of the different ones. This is Management Cloud there. Another one with Management Cloud. Visual Analyzer. I'm not sure which one this one is. That's Apex. Yeah, there you go. Sorry. That's Apex. And so the accessibility that's built in actually brings a lot to your own applications. We take accessibility so strong in Oracle that we actually took the documentation for all of the touch and the gestures and the keyboard interactions, and we split that out into a separate documentation book so that if you build an application using Jet, you can take that accessibility book and include it with your own product documentation and get closer to meeting those accessibility guidelines as well. I mentioned 28 languages, 196 locales now, and we're mobile ready. So every single component has touch and gesture all built into it. We provide native themes for iOS, Android, and Windows 10. We don't do Windows Mobile, we do Windows 10. And so things like, drawers or off canvas type situations, or pull to refresh, these are all built in. And so we do them in a very intelligent way. So pull to refresh is simply a region that when you pull to refresh, it fires a callback method. You go decide what you're going to do when you're pulling to refresh. We don't. So we just pass back a callback method, and you can go do whatever you want. And it's simply on a region. So you can set pull to refresh on a div or on some other thing that you want it to do. We have swipe to reveal. Again, set up with callback. So you swipe it one way or swipe it the other, and you decide what it's going to do. We have sticky headers. So in our list views, you can scroll things up and it'll actually stick the headers on it. We have indexers, which are actually separate controls. You can attach an indexer to a hierarchical data source, and we'll index it for you. So you can add those things in. And of course, lazy loading. So load on scroll. So as you scroll up, it'll just load more on scroll. And of course, all of these are themed for the native OSs. So if you're seeing that little spinner that's showing up, if you're on iOS, it would be an iOS spinner. If you're on Android, it'll be an Android spinner, and so forth. So all those are natively themed. We've got routing built into it, but we've also got animations and the ability to determine which way you're going on your animation. So as you're drilling into things, you can actually set a flag saying I'm going down or I'm coming up, and the animations can reverse automatically. Oh, also on the languages, I didn't point out, but the languages, we also support right to left languages, so Hebrew, Arabic. And if you change the dir attribute on the document, we automatically reverse everything. So you'll notice when you start looking at the cookbook or you start looking at the code, everything that we do is start and end. We don't do left and right because everything can reverse. Start becomes the right when you're in an RTL language, not left. But you set everything, you set the icon as the start icon in your buttons, or in a menu, you want the start icon to be this and the end icon to be that. When you go into RTL, we'll just reverse everything for you. And it's all done automatically inside the product. You don't have to change anything. It's all open source, believe it or not. I know that's a complete oxymoron, Oracle and open source. It doesn't even roll off the tongue very well, does it? He does, he really does. We open source under what we call the UPL license, which is Universal Permissive License. And it's one step above MIT. It's just short of basically public domain. You can do anything you want with this. I had a 5-email exchange with a poor customer that was like, is it open source? Yeah, it's open source. You can do anything you want with it. Yeah, but okay, that's fine, but where's the other license? And I'm like, no, that license, it's just a paragraph. And he's like, no, but it's Oracle. There's got to be more to this than that license. And we went back and forth 5 times before he finally was like, okay, I'll go look at it. Yeah, what's the catch, right? So you can learn more about Oracle Jet by just going to oraclejet.org. That'll take you to our website. Or follow us on Twitter at OracleJet. That's our main social feed. That's where we do all of our announcements and everything else. We have this really cool training course called a MOOC. I had never heard of a MOOC until I was asked to write one. It's called Massive Open Online Course. If you've ever taken a Udemy course or you've taken something of that nature, those are MOOCs, believe it or not. Those that do online training, supposedly it's one of these hidden words that they do. But we produce a 3-week free open course that it's designed for professional people, but it's an introductory course. It takes about an hour a day. You get little YouTube videos that are, I think the longest video is 8 minutes. They're usually around 5 or 6 minutes. You watch that video, it introduces a concept. There's some homework that you go do. and you take about an hour a day. There's 3 weeks of it. At the end of each week, there's a quiz. Pass each of those quizzes at 70% or higher, and you get a certificate. Ooh. Yeah. MOOC. This year, the certificates are like real. You can actually, they're the type of certificate you can add to your LinkedIn profile. They're under your certifications on LinkedIn. Last year it was a piece of paper with mine and Gerhion's signature on it. It wasn't as cool, sorry. But you can get to that by just going oracle.com/go-to/jet. Really easy, oracle.com/go-to/jet, and it'll take you to that training, and you can register. It just started yesterday. It's a self-paced, so you can just take it as long as you want. We're going to have it open for probably a month plus. So that's it from me. Any questions about Jet or any other, I mean, even Angular or React or anything else within this enterprise space? I've pretty much studied them all. I think Jet's probably the best, but I'll let you guys decide. But any questions? Yes? It is. We actually provide SaaS, SCSS themes or SCSS source files for our entire theme, including the iOS, Android, and Windows themes. So we actually have a thing called Theme Builder that allows you to go in and follow instructions, and we've got in the command line tooling for Jet, you can actually edit the SCSS, and it has a watcher built into it, and it'll auto-compile it and give you your new theme. So if you, again, going just to oraclejet.org, and when the site comes up, go to Learn. And there's the training right here. Here's the hands-on lab, which is an open source project on GitHub. You can go and do this hands-on lab as well. And down here is Theme Builder. And Theme Builder is kind of cool. I know we're at the top of the hour. Whoever's coming in next, they can come on in. But it gives you instructions on how to do SaaS and how to work with all the theme builders and stuff like that. So yes, you can. Very easy. All right. Well, thank you very much for your time.